Hey, Trig kids, today we're looking at lesson 4.2, transformations of the sine and cosine graph on Trig with Mr. Forbes. Notes out and away we go. All right, so far we've looked at two parameters for our sine and cosine graph. We've looked at y equals sine x is our basic sine equation. Y equals cosine of x is our basic cosine equation. And we looked at the parameters a and b, where remember the amplitude is a. It's actually the absolute value of a. It's the value used to find period is b. The formula for period is 2 pi over b. We're now going to explore two more parameters for periodic graphs, c and d. And that's going to look like this. Y equals c plus a times sine b quantity, x minus d, c plus a cosine b times x minus d. We're going to do this. Hopefully we will have done this by the time we start class. If not, we're going to do that in our next class period. We're going to use GeoGebra to kind of explore this better, and so you get a better mental connection for what these parameters do to the graphs. We're going to define a phase shift as a horizontal translation of a circular function. In the last lesson, we looked at a horizontal stretch and shrink, and that was by changing the period. Now we're going to look at a horizontal shift. We're going to call that a phase shift, left and right. And that's going to be the value d. D is going to be the phase shift. The argument is the x minus d part of the periodic function. The actual phase shift is what makes the argument, and that is x minus d equal to 0. And that's going to determine our phase shift. We're going to look at that first. Then we're going to come back and look at c. C is going to be the vertical shift. Just like we looked at in college algebra, adding and subtracting makes a graph go up and down. That's what C is going to do. D is going to make the graph go left and right. So let's look at an example. So graph y equals sine of x plus 3 pi fourths over 1 period. Again, the first thing we want to do is establish all of our parameters. A is still 1, because that's 1 times sine. B is the number in front of x, that's just 1, or the number outside the parenthesis is 1. D is our phase shift, and our phase shift is going to come by setting the parentheses x plus 3 pi fourths equal to 0. So x is negative 3 pi fourths. That's our phase shift, negative 3 pi fourths. So it's going to be, D is actually the opposite of that value. So D is negative 3 pi fourths. Our period then is 2 pi. Our amplitude is 1. The points on the x-axis are the hardest thing to find on the graph. This is different from the last lesson because we're not starting at the origin. Our phase shift is going to move us away from the origin. And so we're going to use this methodology to help us get our points. We know that our starting point has to be at the start of our phase shift, and that's negative 3 pi fourths. We know we're going to end. So there's several ways we can think about this. Here's one way you can think about this. So our starting point is our phase shift. Our first quarter point has to be at the starting point plus 1/4 of our period. Well, our period's 2 pi, so that's got to be negative 3 pi fourths plus, because our period is 2 pi, 1/4 of our period would be pi halves. So pi halves minus 3 pi fourths would be negative pi fourths. Our midpoint would be our negative 3 pi fourths plus half our period, that's pi. So our midpoint would be at pi fourths. Our third quarter point has to be at our phase shift starting point, negative 3 pi fourths, plus 3/4 of our period, that's 3 pi halves. And that's going to end up at 3 pi fourths. And our ending point has to be our negative 3 pi fourths plus 2 pi, and that is 5 pi fourths. Therefore, we can sketch our graph. So we can go by pi fourths. And so this would be negative pi fourths. This will actually be negative pi halves that we're not using. This is negative 3 pi fourths. Here would be pi fourths. Here's pi halves that we're not using. Here is 3 pi fourths. There's pi that we're not using. And then there's 5 pi fourths. And then our max, because our amplitude is 1, is between 1 and negative 1. And we're graphing sine. So sine starts at 0. It's going to go up at negative pi fourths, back to 0 at pi fourths, negative 1 at 3 pi fourths, and back to 0. And there's our happy little sine graph with our phase shift. So what did our phase shift do? Because we added a 3 pi fourths here, just like back in college algebra when we looked at graphs, it's the opposite when we plug in. So that actually shifted our graph to the left by 3 pi fourths. Let's look at example 2. Example 2 is a graph of y equals negative 2 cosine x minus pi thirds. We're going to graph this over one period. Again, the first thing we want to do is establish our parameters. The amplitude is 2, or a is negative 2. The a value, the number itself. Amplitude is 2. The graph is reflected because we're negative. So again, for cosine, we're going to start at the lowest value first and then go up instead of starting at 1 and going down. B is the number in front of the parentheses. That's 1, so our period is still 2 pi. D is our phase shift. To find that, we're doing x minus pi thirds equals 0. So D is pi thirds, so our phase shift is pi thirds. So we're going to look at another method we could use to do this. We know our starting point is pi thirds. Again, we can come back and add our values of the period. We can also do this the method we did in the first video in 4.1, and that is we can go ahead and find our endpoint. We're going to have to do some fraction addition here. But if we add 2 pi, that's our period. That's got to be our endpoint. In denominators of 3, 2 would have to be 6 thirds. So 6 thirds plus pi thirds would be 7 pi thirds. Then we would want to find the half. To find the half, the midpoint, we're going to add 1 pi plus 7 pi would be 8 pi thirds divided by 2, and that's 4 pi thirds. And then we want to find the middle of those. We're going to add and divide by 2. So 1 pi third plus 4 pi thirds would be 5 pi thirds divided by 2 would be 5 pi sixths. And then we can see from that pattern that this would have to be 6 pi sixths. I did that wrong. 4 pi thirds plus 7 pi thirds is 11 pi thirds. Divide that in half would be 11 pi sixths. So that's another method you can use. Again, you can also use this method. We're going to start at our phase shift, which is pi thirds. The starting point is pi thirds plus a quarter of our period. That's pi halves. So pi thirds plus pi halves. There's our 5 pi sixths. Our phase shift, pi thirds plus half our period is plus pi. And that gets us to 3 thirds pi plus 1 third pi. There's 4 thirds pi. Our phase shift plus 3 pi halves gets us to our 11 pi sixths. And pi thirds plus 2 pi, that gets us to our 7 pi thirds. Here our amplitude is 2, so we're between 2 and negative 2. And we're starting at pi thirds. And we're going to go to 5 pi sixths, 4 pi thirds, 11 pi sixths, and 7 pi thirds. This is a cosine graph. So we start at the max and go to 0, but it's a negative cosine. So we're starting at -2. Then we're just following our points. We're going to 0, our maximum of 2, back to 0, back to -2. And again, especially with the cosine graph, we want to show that this continues. So we're going to have our curve come back up. It doesn't keep going down because that's the maximum. So be careful about that with your graphs. And there's a graph over 1 period. Example 3. Now let's look at a graph over 2 periods, plugging in all of the parameters. Note, the first thing we want to do is factor out a 2 in the argument so that x has a coefficient of 1. That will help us get our correct phase shift. So our new equation is going to be y equals 3/2 cosine. We want to factor out the 2 to get the x to have a coefficient of 1. To do that, we have to pull a 2 out of the pi, and that's going to leave pi halves as our factor. And the way to check that is to go backwards, use distributive property, and see if that would give us the right parenthesis. 2 times x is 2x. 2 times pi halves would give us pi. So whenever we factor out a number out of something that doesn't have it, we're just going to divide by that same factor. Therefore, our amplitude, our a is 3/2, our amplitude is 3/2, our b is 2, therefore our period is 2 pi over 2, which is pi. Our d then is, set this equal to 0, is pi halves, so our phase shift is pi halves. And there's all of our pieces. So we're going to look at how we can get the numbers then for our second period, because again, this is graph over 2 periods. Make sure you read the directions of the homework question to know how much you need to graph. So we're going to start at our starting point. That's our phase shift. So we're starting at pi halves. We know our period is pi. So again, there's a couple ways to do this. You can either go to the endpoint by adding pi, which would be 3 pi halves, or you can add quarter values of our period, which is pi. So our first quarter point has to be pi halves plus a quarter pi, which is 3 pi fourths. And then we have pi halves plus half our period, which is pi halves, which is pi. Our third quarter point would be a pi halves plus 3 pi fourths, and that is going to be 5 pi fourths. And then our final point is pi halves plus pi, and that's 3 pi halves. So there's our first values. To get our second period, we're going to remember that our end point that we're ending on is going to be our starting point for our second period. So that's also 3 pi halves. And then we can just repeat the process. So this is 3 pi halves plus pi fourths, and that's going to be 7 pi fourths. 3 pi halves plus half the period, pi halves, and that's going to be 2 pi. 3 pi halves plus 3 pi fourths, and that's going to be 9 pi fourths when we do the addition of the fractions, and 3 pi halves plus pi, and that's going to be 5 pi halves. So there's our second period numbers. And there's another way to do that as well, and this may make more sense to you. We're going to use whatever is our first value and add our period to it. So this is pi halves plus pi. Notice that gets us our 3 pi halves, same number. Here we have 3 pi fourths plus pi. That's plus 4 fourths. That gives us 7 pi fourths. Pi plus pi. There's our 2 pi, our middle number. Our 5 pi fourths plus pi. Again, we're adding 4 fourths, which is 9 pi fourths, that number. And 3 pi halves plus pi, which is 2 halves, which gives us our 5 pi halves. So whichever method works better for you, you're welcome to use to get the numbers. But we're going to start here at pi halves. And here we go, 3 pi fourths, pi, 5 pi fourths, and 3 pi halves. Then we go to our next one, which is 7 pi fourths, 2 pi, 9 pi fourths, and 5 pi halves. And we're sketching cosine. The amplitude is 3 halves. So I'm just going to put a mark here at 3 halves and a mark here at -3 halves. Cosine starts at the positive maximum. So we're starting up here at 3 halves at pi halves. And we're going to 0, our minimum, our 0, our maximum, back to 0, our minimum, our 0, and our maximum. So here's our happy little cosine graph. There. So there is our phase shift. And the last thing we want to look at is vertical translation. A vertical translation results from adding or subtracting a constant outside of the argument. It moves the graph vertically. This is the C in the equation y equals C plus A sine B, quantity x minus D. So we're going to graph y is equal to -2 plus 3 cosine of 2x over 2 periods. Again, the first thing we want to do is establish all of our parameters. We're going to see that our C is -2. That's going to shift our horizontal axis down 2. Our A is 3. Our B is 2. So our period is 2 pi over 2, which is pi. Note D actually is 0. There is no phase shift. So our starting point, we're starting at 0 because there is no phase shift. Our period is pi, so we have to end at pi. Halfway would be pi halves. Our quarter points would be pi fourths, pi halves, 3 pi fourths, and pi. So again, here it's just easy. We can count up just by pi fourths. So next would be pi plus pi fourths, and that would be 5 pi fourths. This would be pi plus pi halves. And I made a mistake. I did not leave room for that one. So remember, our starting point for our second period is the same as the end point from our last period. That's just pi. So now we have pi plus pi fourths, and that's 5 pi fourths. Pi plus pi halves, which is 3 pi halves. And pi plus 3 pi fourths, which is 7 pi fourths. And pi plus pi, which is 2 pi. That's one way we can do it. Or we can just keep adding by quarter values of pi. Again, our ending points can be the same as our starting point. And we'll just keep adding by quarter values of pi. That would be 5 pi fourths. Plus 1 would be 6 pi fourths, which is 3 pi halves. 6 pi fourths plus 1 would be 7 pi fourths. Plus 1 would be 8 pi fourths. There's our 2 pi. So again, however you see that, you're more than welcome to keep doing that. So now we want to look at the graph. And so I'm going to take all that information from above, but note now we have a vertical shift. So my x-axis has to shift down by 2. So I'm going to go ahead and put a solid line that was the original axis. I'm going to put a dashed line for our new axis. Then I'm going to sketch our amplitude. Our amplitude is 3. So up 3 gets us to 1. Down 3 gets us to -5, right? But our amplitude, remember, amplitude is always positive. So there's 3 for our amplitude. We're starting at 0. And if you want to put your numbers on your new axis, that's fine. If you want to put the numbers on your old axis, that's fine. I find it helps me to put it on the new horizontal axis as I'm sketching my graphs. And so here we go. This is pi fourths, pi halves, 3 pi fourths, and pi, 5 pi fourths, 6 pi fourths, which would be 3 pi halves, 7 pi fourths, and 8 pi fourths, which is 2 pi. And again, we are sketching a graph of cosine. Cosine starts at the positive maximum. So we're starting at 1, going to 0, going to our minimum, back to 0, and back to our maximum. And that process repeats for our second period. We're at the maximum, go back to 0, our minimum. And I say 0, meaning the x-axis, back to the x-axis and back to the maximum. So there's our graph again for cosine. We want to show at the ends that it doesn't go above the value of the amplitude. So we want to, again, curve and go back down as such. So there's our sketch of the graph of -2 plus 3 cosine of 2x. Again, you might put that in your calculator to sketch it, to see what the graph looks like, to see if you got close to the same idea. And we're going to look at one more. Graph the equation has all 4 constraints, A, B, C, and D in it. So we're going to graph y equals 4 minus 2 sine of 3x minus pi thirds all over 2 periods. So the first thing we want to note is we need to factor out a 3 to get the coefficient of x to be a 1. So our new equation is going to be y is equal to 4 minus 2 sine 3 comes out. There's already a 3 in the denominator, but we're still factoring out another 3. That means another factor of 3 has to go to the denominator, and that's pi ninths. Again, the way to check that is to multiply back. 3 times x is 3x. 3 times pi ninths is pi thirds. So there's our check step. Now we want to see all of our values. And so we see that c is 4, which means we're going up 4. Our A is -2, which means our amplitude is 2, and it's reflected. Our B is 3, so our period is 2 pi over 3, and our D is pi ninths. So here it's really important that we be very careful and very deliberate about making the correct points. So we have our starting point, our first quarter, our middle point, our midpoint, our third quarter, and our end point. And we need to do that for our first period and our second period. And then we'll sketch our graph. So where are we starting? Well, we know we're starting at pi ninths. We're going to go one period, which is 2 pi thirds. So we're going to end at pi ninths plus 2 pi thirds. To be common denominators, that's got to be a denominator of 3. That would be multiply top and bottom by 3. That would be 6 pi ninths plus pi ninths would be 7 pi ninths. So we're ending at 7 pi ninths. Again, another way to do this is to figure out your quarter values of the period. So our quarter values would be 2 pi over 3 times 1/4. And that's going to simplify the 2 and the 4. That's going to be pi 6. So each time we're going up by a value of pi 6. So pi ninth plus 1 pi 6. And if you need to, you can do that on your calculator. Common denominators is actually 18. So that would be 2 pi ninths plus 2 pi 18ths plus 3 pi 18ths, which actually gives us 5 pi 18ths. We'll add another, because we're in 18ths, we'll add another 3 pi 18ths. That gets us to 8 pi 18ths, which is 4 pi ninths. We'll add another pi 6. Again, you can use your calculator if you need to. That's 11 pi 18ths. And we end up at 7 pi ninths. We end at 7 pi ninths, so we're going back to start at 7 pi ninths. So again, for our second, we're just going to take our first value and add to pi. You could keep adding pi 6 if you wanted to go back either way. You should end up with 17 pi 18ths, then 10 pi 9ths, and then 23 pi 18ths, and we'll end up at 13 pi 9ths. Now we want to sketch our graph. And I know we're going up, so I'm going to put my horizontal axis down at the bottom. And we have a vertical shift by 4. So here's our vertical shift by 4. Then I want to sketch my amplitude. My amplitude goes up 2. So we're going up to 6, and 4 goes back down to 2. So there's my amplitude of 2. This is a negative, so let's plot our quarter points. So we're going to start at pi 9ths. And we're going to go to 5 pi 18ths, 4 pi 9ths, 11 pi 18ths, and 7 pi 9ths. And then we are to our second period, 17 pi 18ths, 10 pi 9ths, 23 pi 18ths, and 13 pi 9ths. Now we're going to come back and plot our points. This is a negative sign. Negative sign starts at 0 and goes downward. So we are here at pi 9ths, but we're going downward to our minimum of 2, back to our 0, which shifted up is 4, up to 6, back to 4. There's one sine graph. We're going to repeat that process. We're down to 2, back to 4, our middle, up to 6, back down to 4. And we're going to sketch our happy little sine graph, because that was a lot of work. And there's our sine graph. Homework for 4.2 is page 164. We're doing problems 1 through 12, 15 through 20, 22 through 52 evens, 53 through 56, and 58. Have a good day, Maroons.